Isn't controlling a lamp from a smartphone a nice feature to have at home? Today in this video, we are going to build an IoT wirelessly controlled RGB lamp literally from scratch. So we are going to cover ESP32C3 MCU programming to derive WS8212 addressable LED strip and set it to communicate with an MQTT broker running on a Raspberry Pi. We are also going to cover the smartphone user interface that's managed using Node-RED, which is an amazing tool for IoT-based applications. Watch until the end to learn about all these important topics, so without any further ado, let's jump on in. This video is sponsored by PCBWay. I've personally used their services to produce my own prototype for future IoT projects. Ordering your own PCB has never been easier before, with a lot of features like these castellated holes that I've used. Recently, they have upgraded their FR4TG standard to have even better quality with the same price. Alright, so here's my setup. Let's start explaining with this board. Here I'm having the ESP32C3. This module is quite similar to the one that has ESP8266. It's manufactured by Lilygo. And this board gets its power from this jack connector, which is supplying 12 volt. And here I'm having a buck converter that reduces the DC voltage from 12 volt to 5 volt. And at the back I'm having an LDO, a linear voltage regulator, that's dropping that voltage from 5 volt to 3.3 volt, so I can power this ESP32C3. I needed the 5 volt in order to supply this LED strip. Here I'm having 69 LEDs, so the 5 volt on this board is necessary in order to supply this addressable LED strip, WS8212 LEDs. And also I'm having my ESP32C3 connected to an MQTT broker on Node-RED, so I can receive commands sent from my phone in order to control this LED strip wirelessly. So now let me show you. Here I'm having several commands. Let's start with the switch. I can turn on and off the LED strip, as you can see, and I can change its color. I'm having HSV to RGB converter algorithm in my code, and we will discuss this in a minute. And here I'm having two different light effects. The first one will change the color of the LEDs in order to scan all the colors possible. And the other effect will select one color and change it from that color to the white, changing the saturation value of that specific hue color. And this parameter will change the frequency of changing the light effect. Let me show you. That's all. So now let's jump into the code and see how everything is implemented. And we'll also discuss the Node-RED side, where I have also implemented this user interface, and see the parameters that's being exchanged over the MQTT broker. Alright, so here's the firmware running on the ESP32C3. So let's start with the main function, where we have the Wi-Fi connect function. There's actually nothing special here because the SSID and the password of the Wi-Fi network can be configured from the menu config. And after that I'm having MQTT start function, where the IP address and the port of the MQTT broker are passed just like that. And of course the important part here is to register the MQTT event handler, where all the events will take place. So we will receive an event when the MQTT broker connection event occurs. So for example here, when the MQTT broker connection event takes place, we need to subscribe to the topics that the broker offers. So here I'm having 4 different topics which are responsible for transferring data for different functionalities. So here I'm having a separate topic for the lamp switch, color select, color effect mode, and the update frequency of the LEDs. And here I'm having the quality of service parameter is set to be 0, because currently I'm building a simple application and it's not quite critical to acknowledge the published message or not. So I may use this in the future. Alright, this was the MQTT broker connection callback. Now let's have a look at the data reception callback, which will take place when a connected device will publish data to the subscribed topics. And we have that event over here. So whenever a data reception event occurs, the following parameters are stored inside this handler: the received data length, the topic string, and the payload of the received data. And after that, this handler is pushed in the MQTT reception queue, so I can parse this packet later on in order to perform some function. Alright, so now let's have a look at the Node-RED side, which is running our MQTT broker. I'm using ADIS MQTT broker, which is embedded to the Node-RED server that's running right now. This Node-RED server is running on Raspberry Pi Zero that I'm using, which of course has Wi-Fi connection capability. And I'm having my Raspberry Pi is connected over this IP address, so I can access it from my PC. So let's have a look at the MQTT broker settings. Here I'm selecting this MQTT port. You can select any port. So this port will be used by the smartphone in order to access this user interface that will publish messages to this MQTT topics. Alright, so these blue nodes are going to determine the user interface that you can see over here. I have the switch, color select, and these two buttons and one slider, and we have them right over here. And here's the layout that I can play with in order to customize my user interface. So if we take one of the MQTT publish nodes to see its settings, we can see here the Raspberry Pi IP, and then we can see the port that the MQTT broker is running on. And this is the name of the topic. This is important for the ESP32 side in order to make parsing messages delivered over MQTT possible. And of course here we can have a look at the Raspberry Pi CPU usage, which is actually not a lot. As you can see here, I can still use my Raspberry Pi for other purposes. Alright, so now let's get back to our code and continue our explanation. Alright, so we'll have a look at the MQTT packet parser task in a minute. So now let's return to our main and have a look at the RMT configuration function, where the remote control peripheral is used to encode RGB packets that's going to be sent to the LED strip, WS8212 addressable LEDs, which is actually nothing but a PWM signals with a specific duty cycle. And we can see this from the datasheet of the LED. The duty cycle will determine the logic 1 and 0. So every addressable LED will receive a packet of 24 bits that will include the color of red, green and blue, 8 bits for each. Alright, so let's get back to our main, and here the RMT configuration function will do just that. It will configure the remote control peripheral in order to drive the addressable LED strip. This peripheral is mainly designed for remote control decoding and encoding packets, but since it's a multi-purpose peripheral, we can use it for that purpose. Alright, so at the end of the RMT peripheral configuration, I'm copying the important parameters to the RMT handler, so I can use them later on in packet transmission in color effect handler task, and we can see it over here. The transmission function is used right after filling the buffer that's used to be transmitted over the peripheral to the addressable LED strip. But of course this buffer is filled depending on the data received over MQTT. So let's have a look at the MQTT message parser task. We can see it over here. Alright, so this task is based on the FreeRTOS queue. This queue is filled in the MQTT publish message reception. I have covered this part a while ago. So once a message is received to this queue, it will be parsed depending on the topic. We can see here the topics that our MCU is subscribed to, and depending on that task, an action is taken. So here in the color select topic, such message is received, and the values of the hue, saturation and brightness are extracted from this string, and then the extracted values are put in the LED strip handler, so I can use them later on to generate the values in order to control my LED strip wirelessly. And of course we have the switch topic, which will determine if the lamp is turned off or on depending on its state. And after that I have the mode select topic. This will determine whether we are going to scan all the colors or scan one single color and the white color. And last but not least, I have here the frequency select topic, which is responsible for determining how fast we are going to switch between colors in the modes that I've mentioned above. And at the end of the day, after updating the values of the addressable LED handler, these values are going to be used in order to generate the values of the red, green, and blue using hue, saturation, brightness to RGB conversion algorithm. I've talked about this topic in a previous tutorial. I'll put a link to that here in the card shown above. So after generating these values, they are put in the addressable LED buffer and then transmitted over the RMT peripheral to the addressable LED. Alright, so that was the whole story of the IoT lamp wireless control system that I've implemented. Now let me show you the current consumption of this lamp that contains 69 addressable LEDs and show you the final product with a 3D printed case. Alright, so now let's turn on the LED and see its current consumption. You will see the current consumption on the top. I'm having this LED strip connected to my power supply. You will notice that depending on the color change, the current consumption will also change. So here, as you may know, that every single LED here, it contains 3 different LEDs, red, green, and blue. So in order to form the white light, all these LEDs have to turn on. So you will notice that for the white color, the current consumption is the maximum. Yes. So let's turn on this effect, so all the colors change, and you will notice also the current consumption will change as well. And here I'm having this 3D printed case. Once everything is done, I will put this circuit and the LED strip inside this case and see how everything works together. Alright, so here's the final product. As you can see, I've put my circuit, the ESP32C3, and the addressable LED inside this 3D printed box. The transparent material that you can see here is natural PLA. And here I am having my phone connected to the broker. So here I can publish messages. I've shown this before. And here, inside this 3D printed box, I'm having my Raspberry Pi Zero that's running Node-RED, which has the MQTT broker that we have discussed. So let's summarize how the whole thing works together. I have my smartphone connected to the MQTT broker running on this Raspberry Pi, and once it publishes messages, these messages will be received to the ESP32C3 that's deriving this addressable LED strip. So yeah, that's all. I have all the materials, the code, and the circuit diagram shared on my GitHub repository. I hope that you have learned something new from me. Please like this video, share it among your friends, and tell them about useful electronics. Stay tuned for the upcoming tutorials, and bye bye.